factoring quadratic equation, which is a way to write them as a product of similar linear expression. Factoring us solve this equation by finding their roots, also called solution. And our topic objective is that you should be able to understand what quadratic equation is and its standard form, and learn different methods of factoring quadratic equation. For example, splitting the middle term using the quadratic formula, using algebraic identities, and be able to apply these methods to solve example problems and find the roots of quadratic equations. Welcome. Uh, we'll start by introduction and factoring of quadratic. Factorizing the problem is a step towards solving a quadratic equation, and a quadratic equation must be first be made simpler by multiplying its two linear components before it can be factored. And before we go into the factorization of quadratic equation, it is vital to define it and its standard form. A quadratic polynomial yields the quadratic equation when it approaches zero. The quadratic polynomial is defined as x squared plus bx plus c in a quadratic equation with non-zero real values for a, b, and c. The quadratic equation can be expressed as having two roots when the degree is 2. And the quadratic equation can be factored in a variety of ways. For example, one is splitting the middle term using quadratic formula and using algebraic identities. We start by discussing splitting the middle term. The quadratic equation x squared plus bx plus c is equal to 0 is examined first. Our next step is to identify two whole numbers such that ac plus b is equal to 0. AC plus b is equal to 0. And AC is equal to 1 plus 2. And digits 1 and 2 added together equals to b. So that we define these two integers by the main word. 0 is obtained by multiplying x squared by number 1 and x number 2, x and c. Step 4, we simplify and eliminate the common variables. Example, determine the solution to the quadratic equation ax squared plus 7x plus 10 is equal to 0. The answer is as follows. We have been taught to determine the solution of the quadratic equation x squared plus 7x plus 10 is equal to. The answer is as first of all, the formula x squared plus 7x plus 10 is equal to 10. The integers here are 1, 7, and 10 correspond to values a, b, and c. We can infer that AC that is 1 times 10 is equal to 10 since 1, 2, 5, and 10 are all correspondent of 10. Two parts with a total of 7 and a product of 10 would be our choices. When the two components are added together, the result is 7, that is 2 plus 5. Multiplying these two variables yields 10, which is equivalent to 2 times 5. Then we split the important phrase. The formula is as follows: x squared plus 2x plus 5x plus 10 is equal to 0. We simplify the most often used terminology. So the equation will be x into x squared x into x plus 2 plus 5 into x plus 5 is equal to 0. 0 is the result of multiplying x plus 5 and x plus 2. Thus, x plus 2 and x plus 5 make up the components of the quadratic equation. The roots here are, when you equate x plus 2 is equal to 0, so when you carry 2 to the other side, it becomes negative x, it will be negative 2. X plus 5, we equate it to 0, so x will be negative 5. Now, Factoring the quadratic equation using formula. First, we have a look at the quadratic formula ax squared plus bx plus c is equals to 0. We identify two whole numbers such that a plus ac plus b is equals to 0. AC is equal to 1 plus 2, that is equal to 3. Digit 1 and 2 added together equal to p. Combining the two numbers in the formula in the that step, that is 1 over a into ax plus 1. The second number you multiply it by a equals to 0. Then we supply the equation. Then supplied equation must be made simpler as the fourth step. Example: 3x squared plus 7x plus 4 is equals to 0. The factorization formula for 3x squared plus 7x plus 4 is equals to 0. The numbers for a, b, and c in the equation are 3, these 3, 7, and 4, respectively. The values of AC is 12. Find the two integers whose product is 12 and which, when added together, create a 7. 1, 2, 3, 4, 6, and 12 are the variables that make up 12. The sum of the two components is 7. 12 is the result of adding these two variables together. It is the same as putting 1 equals to 3 and 2 equals to 4. After multiplying 1 over a by ax plus 1, and we end up these two numbers. There is no value with respect to ax plus 2. 1 over 3x plus 3 minus 0 is equals to 3 times plus 4. So x plus 3 minus 0 is equal to 3 times plus 4. So x must be determined so that 3x plus 1 over 3x plus 4 is equal to 0. When x plus 1 is cubed with, then we get 3x plus 4, the result is 0. Then the quadratic consists of two parts, x plus 1 and 3x plus 4. By solving them, we obtain the roots x is equal to negative 1 and negative 4 over 3. Then we now go to the other step using the formula to find a quadratic proper rule. The factors of quadratic equation in x are x minus p and x minus q respectively. When p and q are factors of the equation in x, in light of this, we can use the quadratic formula to factor the quadratic equation. A quadratic equation's component can be represented by using the quadratic formula to determine the equation's root. Using the following quadratic formula, one can find the answers to the quadratic equation problem ax squared plus bx plus c is equals to 0. The formula for x is as follows: minus p plus or minus the square root of b squared minus 4ac you divide by 2a. And after the formula is simplified, the values of a and b can be inserted to obtain the roots. Then we have the last step, that is factor the quadratic equation using algebraic identities. This approach can only be applied when the left-hand side of the quadratic equation takes the form of a squared minus 2ab plus b squared, or a squared plus 2ab plus 2 plus b squared. According to what we understand, a squared is either to 2ab and b squared and multiplied by 2 to determine the values of a and b. The product of a and b divided by 2 equals to 2. So a minus b is equal to a squared minus 2ab plus b squared. A minus b times a minus b equals to a squared minus b squared is equals to a plus b, a minus b. Thank you.